Okay, this session is on estimates. By the end of the lesson, we will have strengthened and extended our mental methods of calculation to include decimals, fractions and percentages, and also be able to make and justify estimates and approximations of calculations. So just to start off with, we need to think about which of these numbers can be approximated and which can be given exactly. Okay, so as we go down the list, number of people in the crowd, that can be approximated. So if you think of a newspaper article, they will most likely say there were over 41,000 people in the crowd. Okay, so this one is going to be approximated. The score 2 to 1, that's going to be exact. Time of the first goal, if you were talking to your friend, you'd probably say that the first goal was at around about 40 minutes, so this one can be approximated. Price of a pie has to be exact, and the price of the tickets for the children, so 33% off the normal ticket prices, this also has to be exact. Okay, so that people know exactly how much they are paying. Okay, so here's an example. It says explain why these calculations must be wrong. So the first one is 23 times 45 equals 1053, and part B is 19 times 59 equals 121. So have a think to yourselves why these calculations are wrong. So for the first one, the last digit should be a 5, okay, because the product here is 15, okay, so it's a product of 15. So we're multiplying something by 5, so the end value has to be ending with 5. Okay, and then the next one, we can say this is about 20 times by 60. Okay, so 20 times 60 is 1,200, so it should be around about this number. So 121 is definitely too small. Okay, so we should be able, or by the end of the lesson, we'll be able to spot things like this and use estimates to just check our answers and make sure that it's roughly what it should be. So this next one, it says estimate the answers to these calculations. So press pause and try to estimate these, and then I'll go through the answers with you. So for the first one, we've got 21.3 plus 48.7 divided by 6.4. So if we don't have a calculator, we can look for the approximate answer. So we can say 21.3 is approximately 20, plus 48.7 is close to 50, and then I can divide that by 6 or 7. I'm going to put 6 for now. So we've got 20 plus 50 is 70. Dividing by 6 is going to be a little bit tricky, and because we're just approximating, we can say instead that we're going to divide by 7. Okay, so because 70 divided by 7 is easy to do, it's going to be 10. So the first one is approximately 10. For part B, 31.2, that's close to 30. So I've got 30 times by 48.5 is close to 50. Okay, so when I work this out, it's going to be 1,500. So this is approximately 1,500. Okay, and when we write approximately, we can do this symbol here, which is two squiggly equal signs. Okay, for part C, we've got 359 divided by 42. If I round that up to 360 and I divide by 40, so that's the same as saying 360 divided by 40. If we divide by 10, that will cancel those two out, so it's 36 over 4, and that's going to give me 9. So 36 divided by 4 gives me 9. So this is approximately 9. Okay, and for part D, we've got 57 times 0.42, so I'm going to say that's approximately 60, and I'm timesing that by 0.4. Okay, I'm going to split the 60 up a little bit. I know that 60 I can have by doing 6 times 10 and then times that by 0.4, and it just helps me to work out this decimal part. So I've got 6 times 0.4 times 10 gives me 4, and all these sums are the same. Okay, so 6 times 4 is the same as 60 times 0.4, and that's going to give me 24. So for the top one, it's approximately equal to 24. Okay, this next example says, by using the inverse operation, check if each calculation is correct. So we need to remember that plus and minus are the inverse of each other, and multiply and divide are the inverse of each other. Okay, so for the first one, we've got 450 divided by 6 equals 75. If we reverse that, we can have 75 times by 6, and I should get that equal to 450. So we can use whatever method you like with the multiplying. So it's 75 times 6. So I've got 70 times 6 is 420, and then 5 times 6 gives me 30. So if I add those together, I've got 450. So we know that that one is correct. For part B, I've got 310 minus 59 equals 249. So if I reverse that, I've got 249. I need to add on 59, and my answer should be 310. I can see, without doing much calculation, that the answer is not correct, because if I've got 9 plus 9, that gives me 18. This answer, 310, it's not ending in 8, so that is not equal to 310. Okay, so that's just a quick check to make sure that we've done the calculations correctly. So the first one says, explain why these calculations must be wrong. So press pause and answer these questions, and when you're ready to move on, just press play. Okay, so far we've had a look at estimating answers. In order to estimate, we also need to know how to round numbers to decimal places. Okay, so we've got an example here. It says the wingspan of a bird is 2.772 metres. Round this number off to the nearest, and then we've got metre, 1 decimal place and 2 decimal places. So you've got the answers here. Just a quick look at the answers. To the nearest metre, it's a whole number. To 1 decimal place, you've got 1 decimal place in your answer, and then to 2 decimal places, you only have 2 decimal places in the answer. For the first one, we've got 2.772, and then to round this off to the nearest whole number, we need to think, which numbers does 2772 lie between? So we're looking at our units column, okay, because that's for the nearest metre, and then we have to look at the one after that, okay, so that's my tenths column. In the tenths column, I've got a 7, Okay, so from my original number, 2.772, the column after the units is the tenths, and that number is a 7. If it's 5 or more, you're going to round the number up to 3. Okay, if it's less than 5, you're going to round it down to 2. So because we've got a 7, it's more than 5, so it's going to round up to 3. So it's approximately 3 meters, correct to the nearest meter. For part B, we're going to use the same method, and we need to round it to 1 decimal place. So the 2.772, it lies between 2.7 and 2.8, because we only want 1 decimal place. So if we look at the tenths column, that's our first decimal place, we want to look at the number after that. Okay, and it's in my hundredths column. Now we need to decide if it's 5 or more. Okay, it is, because it's a number 7, so it's more than 5. So we're going to round it up to 2.8. Okay, we want to take the higher number. Okay, the next one is rounding to 2 decimal places. So it's the same thing. In this case, it's going to be sitting in between 2.77 and 2.78. We just need to decide which one it's going to be when rounded. So we look at the digit after the one that we want, so not the one in the second decimal place, but the one after it, so it's going to be the 2. Is this number 5 or more? Okay, no, it's less than 5, so we're going to round down to 2.77. So that is the answer, correct to 2 decimal places. Okay, so try these questions for yourself. So we're rounding to 1 decimal place, 2 decimal places, and there should be an example for 3 decimal places as well. So press pause and then press play to see the answers. Okay, so if we have a look at the answers, for the first one we've got 6.83. Okay, we want it rounded to 1 decimal place, so we look at the column after that, so that's where the 3 is. Okay, and because it's a 3, we're going to round the number down to 6.8. For the next one, I've got 5.173, and I'm going to round it to 2 decimal places. So we look at the next column, which is at 3, and again it's less than 5, so we round it down to 5.17. Okay, and the next one, 8.36, we want to round it to 1 decimal place. The 6 tells us that we need to round up, so it's going to change to 8.4. 0.4348 to 2 decimal places. We look at the 3rd decimal place. It's 4, so we round it down. So it's going to round down to 0.43. The next one is 3.6, and the last one is a little bit more tricky. The 3rd decimal place is a 9, so we round it up to 52. Okay, because we can't put the 9 up anymore. If we think of that as 99, 99 will round up to 100, so we need to add an extra 1 into the units column. Okay, so it's approximately 52. Okay, so we're going to just do a bit more practice rounding to 1, 2 and 3 decimal places, because we're going to need this when we are estimating answers. Okay, so press pause and try these questions for yourself. Then when you're ready, just press play to get the next set of questions. Okay, so for the first set of questions, it's rounding to 1 decimal place. Okay, so I'm just going to pick a couple. So for C, I've got 3.54. Here is my first decimal place. Okay, so I need to look at the one afterwards, and that tells me whether I round up or down. So because it's a 4, we round down to 3.5. Let's do the last one, F. So 9.99. I'm rounding it to 1 decimal place, so there's my first decimal place, and this 9 tells me whether I round it up or down. So because it's a 9, we round it up, and then we can't round the 9 up to 10, we need to add it on to the units column. Okay, so that 9 becomes 10. And because it's to 1 decimal place, we just have to put the 0.0 as well. Okay, when we round to 2 decimal places, let's do B. So here is my second decimal place. Okay, and I need to look at the one after that, which is a 7. So we know that we have to round it up to 2.57. Okay, if I look at D, here is my second decimal place. The one afterwards is a 9, so we have to round up to 1.44. Okay, for F, we've got 5.0035. My second decimal place is here, and the 3 is the one that tells me whether I round up or down. So because it's a 3, we round it down to 5.00. Okay, I'm rounding to 3 decimal places. For the first one, we've got a third decimal place. The one afterwards tells us whether we round up or down. So because it's a 4, we're going to round down to 14.243. The next one, let's just do B. So there's my third decimal place. 7 tells me I need to round up, so I'm going to have 2.537. For C, there's my third decimal place. 7 again, so I round it up, so I've got 6.574. The next one is 12.498, because that's the one tells me that I round it down. And then this one I keep the same. There's only 3 decimal places there. And the last one is going to be 5 points. So there's my third decimal place, and the 5 tells me I round up, so that's 5.8. If I just think of it as 79, because I have to round up, this 9 becomes a 10, so it becomes 5.880. Okay, for these questions we're just going to have a little bit of practice multiplying by decimals. So we've already had one example earlier on, so let's go through the first one together. We've got 60 times by 0.7. Okay, multiplying by decimals is a little bit tricky, but for this first number, 60, I know that's just 6 times 10. Then I multiply that by 0.7, and I know that 10 times 0.7 will give me a whole number. So that's just going to give me 6 times 7. Okay, which gives me 42. So you're going to go through and do the same thing with each of these. So press pause, and then I'll go through a couple of the answers when you're ready. Okay, so let's just go through a couple of them. So if we try D, 30 times 0.4, so 3 times 10 gives me the 30, and that's multiplied by 0.4. So that's just 3 times 4, which is 12. Okay, if we try K, 30 times 0.5, I know that's going to be the same as 3 times 5, which is just 15. Okay, for these next questions, you're going to estimate the answer to each of these problems. You need to decide how you're going to round these numbers. Okay, so it's up to you whether you round to the nearest whole number, to the nearest 10, or to one decimal place. Okay, it's up to you how you round them, but it needs to be numbers that are easy to work with. So for the first one, I've got 2,768, take away 392. Okay, I could round it to the nearest 10, or I could just round it to one significant figure, so to the 2, and so it'd be 2,000, round up to 3,000. So for part A, 2,768 is close to 3,000, and then I take away 400. If you decide to round to the nearest 10, so for example you'd have 2,770 minus 400, that gives you a more accurate answer, but it's a little bit more tricky to work out. So I'm going to stick with the first one that I said, 3,000 take away 400, and that's going to give me 2,600. So the first one is approximately equal to 2,600. So you're going to go through and try those questions for yourself, and then you've got a worded question as well, which you need to work out. Okay, so press pause and then try those. Okay, I'm going to go through, I'll just go through G. So we've got 135.7 minus 68.2, then divided by the 15.8, and then minus the 8.9. Okay, so if I round these numbers, I can round 135.7 up to 140, take away 70, divided by 50, I can try 16 minus 9, 140, take away 70 gives me 70, 16 take away gives me 7. So it's just 70 divided by 7, which is 10. Okay, for question 7, it says Delroy had £10. In his shopping basket he had a magazine costing £2.65, some batteries costing £1.92 and a tape costing £4.99. Without adding up the numbers, how could Delroy be sure he had enough to buy the goods in his basket? And then explain a quick way for Delroy to find out if he could afford a 45p bar of chocolate as well. So for the first one, to make sure that we've got enough, so we've got £10 and then he's picked up these things. So I'm just going to round it all up to the nearest pound. So the £2.65, I'm going to round up to £3. And then I've got £1.92, which is approximately £2. £4.99 is close to £5. So I know that gives me £10, so I do have enough. And because I rounded up with all of those numbers, I know that I definitely have enough for the £10, and I will get a little bit of change. So explain a quick way for Delroy to find out if he could afford a 45p bar of chocolate as well. So looking back at these amounts, so £2.65, how much change would you get from the £3? So how much more did we add on? We added on an extra 35p. From the £1.92, we added on an extra 8p. And then from the £4.99, there was an additional 1p. So this is my change from each of those items. So if I add that up, I've got 35 plus 9, and that gives me 44p. Okay, so I haven't got enough change. I'm 1p short from getting the bar of chocolate. Okay, so now we're going to estimate the answer to each of the following. And we've got decimals here as well, so we're going to have to round and then also use the method of multiplying with decimals. Okay, so if we do the first one together, so we've got 72 times 0.56. 72 is close to 70. Times that by, I'm going to round that up to 0.6. So now that's a simple calculation and we've practiced it before. So it's just 7 times by 6, and that gives me 42. Okay, so the first one is approximately 42, and you're going to use the same method for the rest of the questions. Okay, for question 9, we've got 62 divided by 0.39 can be approximated as 60 divided by 0.4, which is the same as 600 divided by 4, and that gives me 150. Okay, so we're going to estimate the answer to each of the following divisions. So if we go through the first one together, 62 divided by 0.56, and I'm just going to write it like this because it helps us to see how to cancel it down. Okay, so if I approximate these numbers, so 62 is close to 60, 0.56 is close to 0.6. Okay, I don't want to have a decimal on the bottom, so I'm going to multiply this by 10. If I multiply it by 10, I have to multiply the top number by 10 as well, okay, to keep the answer the same. So whatever I do to the top, I have to do to the bottom. So I've actually got 600 divided by 6. So how many 6's go into 600? It's going to be 100. Okay, so that's the answer to the first one, and you're going to do the same thing with the rest of the question. So maybe we'll go through one more together. So for question 9b, I've got 139 divided by 0.67. So I'm going to round the 139 up to 140. Then I divide that by 0. And I round it up to 7, so divided by 0.7. So we want to keep the fraction the same, or the division the same, but I want to get rid of that decimal. So to get rid of the 0.7, I can times it by 10, but that means I also have to times the top number by 10 as well. Okay, so I get 140 times by 10 is 1,400, and then divided by 7. Okay, so to answer this, so we've got 1,400 divided by 7. If I just think of it as 14 divided by 7, I get 2, and then I've left out my 100 at the end. So it will be approximately 200. Okay, so go through the rest of question 9 and try and answer these questions. Okay, just to finish off, here are some questions for you to try in your own time. So it's just an overview of what we've done already. And just going back to our title page, so this lesson should have strengthened and extended our mental methods of calculation to include fractions, decimals and percentages. And also we should now be able to make and justify estimates and approximation of calculations.